Yeah, that's that. So my first broad question is, so Frank had initially requested that I um, construct like a circular ROI to be placed on the surface. But my understanding was that at this point, that's not feasible to do in the pipeline, that the ROI analyses had to be done in the volume. And so I ran all of my analyses, using the volume-based pipeline. But one question that Jason and I had was whether I should go back and rerun it with surface-based. And then the other question, which I already talked to Alfonso about previously, is how does one go about concatenating multiple ROIs into like a larger cohesive ROI? So like, for example, Frank wanted me to combine like SMA, pre-SMA, and some other regions together and see if that, was better than looking at them in isolation.
Okay, so let me see. The second question, the how to combine ROIs, I mean, there is a hard way of doing it. I can explain a little bit how we would do it right now, but then perhaps you can suggest ways in which perhaps we could simplify this process and make it a little bit simpler, because I imagine that this scenario happens relatively commonly. So right now what you have to do is basically manually create a new ROI that specifies the new that has the region that combines all the regions in the original section. So the way to do that would be like creating an OR mask through multiple original masks that contain the individual segments or blocks of your new ROI. So how is your original? What are the things that you're trying to combine? It depends. Are they part of an atlas, or are they already you have them in individual files?
Yeah, let me share my screen. So there are several of these. Oops, may not see it.
Oh, you can't, duh. I'm not used to being the one hosting the session. All right.
Can you all see this?
Let me full screen it.
Yeah, I can see that.
Yeah, like so like this is just one example where combine pre-SMA, SMA, or these regions here together.
Right, and the regions of pre-SMA, SMA, are they defined from our speech lab atlas, like a cortical?
Yes.
Sorry,
yeah, these will be speech lab ROIs.
And they are surface-based, all of this, right?
Well, I don't know, because I ran all of my analyses with the volume-based.
Oh, okay, but you were also using ROIs in original analysis, or using a different set of ROIs?
Sorry, repeat that.
So you run already an original set of analysis using ROI level based analysis, or not yet?
Yes, but with each treated individually.
Right, but if what I'm wondering is if these regions are defined from our speech lab atlases, they are typically defined from an annotation file, and that basically means that they are defined on the surface and on FS average, basically. So if you were using those ROIs, you would have needed to have put in basically surface-based data that has been run through a surface-based pipeline. On the other hand, we have some kind of workarounds. Sometimes people I don't know. I know Jason has converted these surface-based ROIs to an M&I template, just projecting those to an M&I template so that people can use it if they have M&I-based data. Although that is a little bit suboptimal because the transformation between FS average and M&I coordinates is not all that robust, basically across subjects. So I was just asking these questions to figure out which one of all of these potential cases to end up doing analysis using our speech lab ROIs on your data you used. Whether you use a surface-based pipeline and then these surface-based ROIs, or you use an M&I normalization pipeline and then use some alternative. Which one in particular?
I ran it on the volume-based, but I'm wondering if I should do surface-based.
Yeah, these are surface-based ROIs in that atlas.
Yeah, okay, so I need to redo that then. Okay. But like, for example, in another analysis, right? So let me go back here. Let's see. Yeah, so Frank wanted me to compare the patient and the control groups, looking at these nodes that had been identified in a previous meta-analysis comparing stuttering and neurotypical speakers. And for these, I got the M&I coordinates for each node, and then I created an ROI in Con, and I specified like what my radius was and so forth. And that, I mean, would that also be done? That would be done in the volume, right?
Right. If you use like Con toolbox to define these ROIs from M&I coordinates, you end up having like a volume in M&I space that defines these ROIs, and then you can use those ROI defining files for your M&I pipeline.
So that is fine, but for the speech lab ROIs, you're saying like these, like this is based on like a surface coordinate, or I don't know what.
So if you want to be an M&I,
Right.
sounds like Jason has a transformation that kind of puts those surface spaces into M&I space. You can't rerun it in surface space, or if it like won't match up if you rerun it in surface space. If it's imperative, it's in volume space. Jason has ROI that'll work with that. It sounds like it's just, if I'm getting this right, it's better though to use the surface space because that's what these ROIs were intended for. So
yes, exactly. I mean, all of these ROIs are defined on FS average space. So if possible, the correct or best way to do them would be to apply those on data that has been run through our surface-based pipeline, so that they have been analyzed through FS average, through free surfer, so we know where the cortical ribbon is, and they are in the proper space, so that the FS average, we know how to map FS average to its subject cortical anatomy. Worst case scenario, when we haven't done that and we haven't run the data through free surfer, and we still want to be able to use these ROIs, there is a workaround for that, but it's not recommended.
Okay, great. Another small question, and I think that Saul actually raised this in one of the prior sessions, was like here it says left hemisphere, but I believe you said it's doing it for the whole brain. Is that correct?
Right, that's true. When you specify LH something, the toolbox will look for whether there is also an RH equivalent file in the same directory, and it will use both.
Okay, wonderful.
So I'll just for the original question, right? And for the original question on how to combine several ROIs. So those specific, if you can you CD to that same folder where you have these ROIs, the LH dot. I think it's called SL ROIs. So it will be in project and be just lab SL ROIs folder.
Is this in the project or project NB?
I think it's in project NB, or at least that's what it says in the ROIs file that you created.
Yeah, yep.
The average?
No,
the project NB BUSP lab, and then SL ROIs, and then I don't quite see it because it's behind in the window, in the text editor window.
Matt, can you just click on your ROI definition configuration file? I mean, the window that has your ROI definition configuration file.
Sorry. Okay.
Oh,
right there. Yep. Oh, yeah. So that is SLF.
So yeah, you're right. So just copy and paste this directory, or I can, if you, let me see. Let me just quickly check. I'll request remote control so I can quickly do this. So what I want to check is that the annotation files are a little bit difficult to work with because we don't have that many tools that work with annotation files. We can read them and we can create them, but it's not easy to change them. So I wanted to check whether we have something else in here that's been already converted to Nifty files or something along those lines. We should have something called, what was the name? It was FS average. It was this file, the one that we were using, right?
Mm-hmm.
Okay, so there should be also a file that is this has been converted to Nifty.
Yeah.
Let me see, it should be called that, and then probably surf.me or something along those lines. No, let me see what I'm forgetting. It's probably surf.img instead of surf.img. Okay, so yeah. So this is an analyzed format version of the same ROIs, and this analyzed version format are a little bit easier to work with. So I'll show you how to combine ROIs with this one. So let me just show you first what this is. So this is just a file that looks very weird because it has these dimensions that are just for surface-based ROIs. It's 42 by I think it's 93 by then 47 times 2. The 47 is for every hemisphere. So if you divide this into, this basically is like a 2 big column vectors. The first row is the left hemisphere, and the first column is the left hemisphere, and the second column is the right hemisphere. That huge vector has been converted into a three-dimensional matrix just so that SPM likes it, because SPM doesn't work very well with these volume files that contain just a long vector. But this is basically a surface level data. This is in FS average. So the number of voxels that you have here correspond to the actual number of vertices that you have in the FS average space for the two hemispheres. And these just contain numbers, right? The values in here are just numbers from 1 to 300, I think it says 54, I won't quite read it. And there should be also a file in there that is called text file, sorry, like this, that it contains the labels for these ROIs. Yeah, so this is telling you basically for every individual number in that file what is the label for that value. So all of the vertices, voxels or vertices in this case, that have a value of 2, they will be those ones that are labeled as gray matter, and the values that have a value of 15 will be, I don't know, I don't quite see what it says in there. I think it says PMC, so FMC, so frontal medial. Okay, excellent, thank you. So yeah, frontal operculum, I imagine, and this is, I don't know what FMC is actually. Frontal medial choroid, no idea. Okay, in any way, the association is between these labels and these numbers that appear in the file. So if you want to combine two, what you have to do basically is figure out which ones are the numbers corresponding to those two, and create a new mask that just has only those two ROIs and as having all ones, and then basically every other voxel that doesn't belong to either one of your two ROIs as 0. So let's actually do it for some actual example. Which ones do you want to combine? Premotor cortex and which one? PMC, ventral premotor cortex, mid premotor cortex, ventral. Let's see. Okay, so let me see if I can find them. So let's see what is the simplest way. Ventral cortex. Okay, so we can do that. Let's see what is the simplest way. I think I can do, how do I get the names easily? Okay, one trick that we to use. How to use a simple way. I'm missing a part, I think. Right, so why is not reading the names? Oh, right. I forgot. Yeah, that's not the simplest way. It was called Okay, this is really not the simplest one, but it's at least one way. So I have in B all of the names of these things, and I'm just gonna remove that portion of the name. Oops.
If it's easier for this tutorial example, we could just do like pre-SMA and SMA.
Right. It was, well, I mean, it's going to be the same. We need to find the corresponding numbers associated with it. The whole idea is basically this. We need to figure out which ones are the numbers associated with those two ROIs. And then we need to create a different file that combines those two or three or whatever number of ROIs that we have. And only those voxels have a value of 1 and everything else has a value of 0. So it doesn't matter that much. But, why B is not liking it. Oh, right, I forgot. Okay, so now we have those. So you can find the names using something like this. Let's see what are we wanted ventral motor cortex, ventral premotor cortex. Then we wanted which other ones we want? Mid ventral cortex and mid premotor cortex, something like that.
Yeah.
Well, let's try with these ones, and then we'll see where we come. Oops, one. Okay, so that should give me the yeah. Sorry, I used the wrong command. Okay. Because it has left and right, okay. Because this is divided into left hemisphere and right hemisphere, so let's just do this for the left hemisphere only.
Okay.
Okay, so those are the numbers that we care about. Those are the 39 corresponds to ventral motor cortex left, and 44 corresponds to ventral premotor left, and so on. And we could have done that manually, basically looking at the lines corresponding to that. I'm just trying to, I don't know, this perhaps is a little bit more complicated, but it's also more general. So whatever number of different ROIs, you can use this syntax to figure out these numbers semi-automatically. And once you have these numbers, then we can create a new file that is going to be, basically we want to create something that like B, remember B is my matrix that has all of these, sorry, I overwrote B with something else, so we just reload it. Oh, and I also overwrote A. That's what happens when you use these common names A and B all the time. I just reload it. And now, okay, so we have B, that is our matrix, our actual data that contains is this huge matrix, three-dimensional matrix, or conceptually this vertices by two. The actual data for each ROI, and this has numbers that go from 100, from 1 to I don't know, a few hundreds. So anything that is, if we find something like this, it was 39, 44, 57, 58. So if we do something like that, we are basically extracting from B the values that correspond to numbers of this list. So we are creating C, basically a different matrix that is going to be just like B, but it's going to have ones for where B had a 39, a 44, a 57, or a 58, and it's going to have zeros everywhere else. So if we look at C, it should have, I don't know, that number of vertices, and that should be basically the sum of these things. If I look at the number of vertices that were in 39, the first region, that should be some number. And then I find the ones that were 44, some other number, and then 57, some other number, and then 58. Is that a 58 or a 59? I'm not reading it very. 58. Okay, so that the sum of these four numbers should be equal to this. It's just like a quick check. So 5,000, 7,000, around 9,000, something like that.
Alfonso?
Yeah, go ahead.
Can you, how did you get the 39, 44, 57, and 58? You said you could take it from the
you can look at, from this text file, you can actually read, if you go to the line 39, that should be the ventral motor cortex, I think. Let me see. It's not.
Yeah, I think it's because not all of the, not all of the numbers are taken up by ROIs. So it looked like in the list of, yeah.
But that's weird because this type of text file assumes that 39 should be that.
But the text, so the text file, line 39, I don't think is not 39, potentially.
Right, but that's not right. Then it should have created a file that it, so let me check when this file was created. That's 2015. Okay, so that might be a problem. Let me see. Let me recreate. Perhaps I'm looking at the wrong file, or I should just recreate it. It was called. It was called con to move the average surface average. No, let me check one thing. I don't remember how to force the conversion because this is probably just checking that the file already exists and I'm not doing anything to it. Just see how can I force the conversion in some way. Well, perhaps I can just edit it. Well, I can just remove the file. Or I can just force this for a second. I will remove it. Let me just quickly change SLFS average and ING. I'm going to call it all SLFS average and ING. What is it around my SLFS average.ing? Oh, it was. No, sorry, it was dot FSL, I'm misremembering the name. It was just something like surf.me instead of anatomy, right? No, okay. So what did I do? I wrote me instead of ing. Yeah, that's it. Okay, so what I'm trying to do here is basically deleting. Remember that I said that annotation files are hard to work with, and I prefer to work with these nifty files that are created that are kind of like secondary, and they contain the same information as these annotation files. But and we have this command, the con annotate to me, that converts this annotation file format to nifty. So I'm trying to rerun that to redo the conversion between the original annotation file and our nifty, and the reason is because I don't like the nifty file that has been created has old way of creating these labels that is, well, it's not the way we use any longer. So I want to redo that. That's why I'm doing all of these things. So the way the command, the con annotate to me works is that if it already exists, the file that it tries to create is not gonna try to recreate it. It's gonna assume that it's just fine. So I want to delete this file so it doesn't find it. So that then I can write the annotation to nifty file again, conversion, and this time it should actually convert it. And perhaps let's see, what did I do wrong now? That might be because I don't have right permissions in here or something along those lines. Let me check. That's weird because it allowed me to change the name of the file, so it should allow me to write in here. I do have right permissions and the USP lab. That's weird. It could be that I cannot. Let me just. I didn't move the text file, so let me do that just in case I don't have right permissions to override this file. That could be it. The text file, I didn't rename it. That means that it will still exist. Okay. Let's try again then. Right. Okay, so now I created so let me just check again this file. Should be correct now. Oh, come on, got it. Okay. Oh, still the same thing. So why then 39? That's weird. Oh, let me think about it for a second. What am I doing wrong? Perhaps right. So perhaps the missing is not because the 39, it's because the 39th appear in Rex because I use Rex. Okay, so that may be it. Okay, so the original way that I did to get the list of the ROI names, they didn't give me the whole list of ROI names. They give me only the list of ROI names that actually appeared in this file, and some of them they don't have any boxes that are associated with this file. So that's what was wrong. So let me just get something a different way to get the ROI names. I can do, let me see. I think this should work if I remember the name of this. No, it was with text instead of text read or something.
I think you put .txtz.
Oh, right. And also a bar in here. And, okay. That, okay. Perhaps I misremember what is the one that I don't need to specify a format. Perhaps I can do that. This one, yeah. Okay, so okay, so this is a bit convoluted way, but this is a way to get all of the names in there without having to go through Rex. Sorry. So I have 364. Let me check that this matches what I have here. So now str 364, 364. Okay, this makes sense. Okay, so these are the names that I'm looking at there. And now I can do the find is member thing to figure out which ones. But now I'm not saying left and right because it's using the new format, which probably is implicit. Left and right. Okay. So let me look at these ones. Oops, MC.
How do you know if it's left or right hemisphere based on?
Because they are they appear in the first column of the data metrics, or they appear in the second column. So it's kind of like irrespective of they basically are in different parts of the data file instead of having, but they all have the same name. So when most of the software that reads this file will assign the name basically from the location of the voxels, whether they are in the first column or in the second column of the data matrix, as opposed to reading it from the file. So we remove it from the file text. I mean, okay, but I am not finding it. Let me see. Because they are still, because I'm using B and it's in str. Okay, so that should give me, if I recall correctly, 8. No, only 6. Why? Because 2 of them are medial and 2 of them are lateral. Okay, so I'm going to give them.
You need PMC. It just right now it just says mid PM.
Oh, okay. So that might be why there's 6 instead of 8. All right, because mid is not for medial. That would be MED instead of MID, right? So
yeah.
That.
There you go.
Okay, there you are. Perfect. Thank you. Okay, so these are the numbers that we care about. Let's quickly double check where they are actually. Sorry. IDX equal, I just put them into a variable, so I have those that I can use. So let's see, 57 should be one of those. They are not necessarily in order because they are sorted by fine. But let me see. One of those should be 57. So let's just quickly check. 57 ventral motor cortex. Okay, perfect. So these 8 numbers are the ones that we want to combine, and they are sorted by left and right. Do you want to have them as a single file that contains both hemispheres, or as 2 different as two different ROIs that correspond to the. So you want to analyze the left and right of these regions, right?
Yeah.
So we can. Okay, so now we can create C as we were doing before, but now we want to make them. The first four is going to be, I don't know, C1. I'm going to call it. Sorry. And C2 is going to be the last four, which are going to be the right hemisphere one. Sorry. Right, and we could actually, I don't know, are you familiar with using these things like SPM write vol and things like that, or do you prefer me to use SPM in calc to so you don't have to load these files and create them manually? You can just write a single command. What do you prefer?
The latter.
The latter, SPM in calc. Okay, so I can show you how to do that. SPM in calc is a very general syntax. It works like this. I think you specify first the list of files that you want to use as original file. So in this case, it will be the FSL average, FS average surf.img. Then you enter the name of the output file that you want to, if I recall, the output file that you want to create. I'm going to call it FS average. What name should we give it to this new ROI? What is a reasonable name for this new ROI that's going to be combining all of these individual ROIs?
New comb ROI.
Something that I don't know. What do these have in common? This is all. Let me see.
Well, precentral gyrus, but
okay.
It's like ventral and mid precentral gyrus, I guess.
Right. Okay, I'm gonna use precentral gyrus PCG as a general name, and then surf.img just to identify that this is still on the surface on this file. Okay, and now you have to enter here the third command to SPM in calc is basically the formula that you want to apply. Typically, you can do anything with SPM in calc really in terms of operations. Typically, you can enter like two input files, one output file, and then say I want to add them. So when you enter multiple files, they are going to get always the names. I1 is going to be the first, the data for the first file. I2 is going to be the second, I3 the third, and so on. So if you want to, for example, if you enter here two files and you just want to add them, you would enter something like I1 plus I2, right? And that would be all of it. You have to give here as a third argument the formula. These are the input files, this is the output file, and then the formula that you want to use. In this case, we want to use a little bit of a complex formula, but we want to figure out I don't think in the formula you can actually, I think you can enter any MATLAB commands. Let me just try this. It's member I1, and then you're going to enter all of these values in here. So, because I don't want to read them incorrectly, I'm just going to copy and paste them here. I don't know if I'm in the correct location. Let me check. Nope.
You're missing the 5 on 57, the first one.
Thank you. Okay, so I think this should work. I'm missing, as long as I can SPM in calc allows me to use arbitrary MATLAB command, which I'm not totally sure whether it does. Okay, so I wrote the name of the file wrong. It's not surf.
Lowercase.
Let me check. It was right. FS average surf. Okay. I'm missing the SL. Yeah, I think all of this is wrong. It's SL, then FS as lowercase. I think like this, right?
Yeah.
Let's try it. Okay, so that should have created a new file. Let me just. I'm gonna. Well, that's fine. Yeah. Push A and B again, or perhaps something else. Okay, let me check whether I should have changed the name because of this. No, that's fine. What did I do? I think I'm missing a parenthesis, right? Oops. There we go. Okay, and now I'm gonna call it C2. Sorry. Okay, so let me check C2.
So is this it here?
Oops, I created all of them. Yeah, that should be fine, right? I should give it a. I created all of it, so left and right together, right? What was the name of the C2 I had written? Let's see. I had written before something that was already using C2 as this. Let me just call this C2B because it's one portion of what I called and this C2A. I'm just quickly checking whether everything looks fine in terms of the dimensionality of the data. So, okay, so C2A was just a match of the left hemisphere regions, C2B was the right hemisphere regions, and the sum of them should be what we found in the new C2 variable. So that, yeah, that looks fine. Okay, so now we have created that file, which is called, what was the name of the file? Sorry.
PCG.
Right, excellent. So all that now we have the file, and the file has ones and zeros, and it's perfectly fine. We just need to give him a label, just to give it a, well, since only has one region, perhaps we can do it a little bit better, right? We can create, yeah, let's do it. The problem with this file currently is that we have put together the left hemisphere and right hemisphere into a single ROI. We don't want to do that. We want to make sure that we break it into two. And so the way to do that is, let's just write a different incalc command for that. So can you imagine how you would do that using an incalc command? How would you create a single file? So basically the same output file, the same input file, but now change the formula so that it contains the left hemisphere and the right hemisphere as two different ROIs. How would you go about doing that? Do you know? Any ideas?
Change the vector to a 2x4 matrix or something.
Yeah, it's a good guess, but not exactly. A bit more manual.
Okay.
Manually, it's a little bit of more complex. Yeah, there's no easy trick.
Yeah, just do it twice. Once with the first four and once with the last four with a different file name.
Yes, exactly. Yeah, so you just do it twice, but then you just assign basically different numbers. So you basically want to put ones for the first fours, and you want to put twos, for example, for the last four numbers. So one way of doing that, for example, would be exactly that. Would be running this member thing twice, doing something like that, and then running another is member command with the one with the second one. But it's going to assign ones to all of them, right? Because it's going to put ones for these guys and then ones for these guys. So we want to make sure that we create twos for those guys. So we have to multiply that by 2, for example. So then when we add, so each member is going to give a one for these values and 0 for everything else. So that is fine for the left hemisphere. And then for the right, we have each member command that is giving us ones for these guys and 0 for everything else. And then we just multiply those values by 2. So now we have 2s for the right hemisphere regions and 1s for the left hemisphere regions. Does it make sense? Do you think it's going to work? It's not a trick question. I do think it's going to work. At least I don't see any obvious wrong things in there. Check. There we go. If we look at the values in C2, we should have now ones and twos. Well, we should have zeros, ones, and twos in these files. Let's just check. Yeah, perfect. We should have. Yeah, I think that's fine. This is because they are read as calc uses the same format. Me remember, I'm worried by seeing this point 000 instead of reading them as integer numbers. MATLAB is reading them as float numbers. So I'm just trying to remind myself where this incalc has a way of specifying that you want the output to be in one particular format. You want them to be integers or something like that. So I'm just quickly checking that. It's something this says. Interp type. So array of flags. The false misnumerity to 416-bit sign shorts. Okay. I thought there was a way to just say that is to use the same one. I don't recall. Well, Okay, so we can just create one D type. Let's do it again, just to avoid potential problems. I'm gonna try to say that we want D type to be, I'm not entirely sure. Do you enter the name or do you enter the SPM type thing, portion of the name? Let me see. Do we have an example? Nope. Let's assume that you enter the number. So we should use what is called, I think it's called SPM type int 8 probably. Let's check. Let's see whether that works. I'm probably missing a parenthesis. Yeah. Okay, so let's try again. Check C2. And now unique. That's even worse. The rounding didn't quite like the rounding. So just remember this. So let me just check. Int 8, I think is 2. And what did I use? Int 8 to 56. Why didn't let's just be yes, perhaps he just wants the mask actually. Let's see. The actual name. Let's try that. Okay. So again. I'm sorry, it was not that. Anyway. Not still not. Okay, let's try again. Type. Okay. I think there is a logical as well, right? I'm not totally sure. No, there's not a logical. There's a yeah, right. Solution 2. I'm misremembering this. I'm sorry about that. Let me do my comparing. Oh, that's brilliant. I think it says that I should be using SPM type, so why is not liking? Okay, I think I've seen this issue before, so let me just quickly try potential fix. Let me just remove this file before we create it, because sometimes doesn't work. I'll just do it manually. I was hoping to be able to use this in calc command. This is pretty simpler. So it's fine. Looks fine. Yeah, it's using that. Okay, so I'm doing something wrong. This is the file that I just created, and so file G this B. Okay, this is just ridiculous. Do you see any mismatch? Do you see any mismatch between the naming here that appears in here and the name that appears in here? By any chance, I see very blurry the whole screen, so that's why I'm asking.
No.
It's like the same name.
Yeah.
Okay, so I'll just do that manually then. I can do that too. And then I'll figure it out later why this doesn't work. Okay. Okay. Um, right, okay. Okay, let's try again then. So. Right. Okay, so let's check. Now it should be fine. There's, yeah, there it is. Okay, so I don't know why. I'll figure this out later. For some reason, the incalc command is doing this weird conversion that it doesn't kind of uses the format that we give him, that we ask him to use. We are asking to write these files as integer numbers, and he's using something else for some reason. So I'll figure that out, and I'll let you know how to use the proper command in SPM in calc to force it to use the proper syntax, to the proper, basically, format for these numbers. But I don't know, a workaround is just to recreate it manually. And this shouldn't be a big thing, because typically when these ROI files are created, if they don't contain exactly integer numbers, the software will handle them still correctly. But I mean, just to be, they should be exactly one. So we want to be precise, and we want to make sure that there is some software packages that are going to fail if you are entering 1 point something, or they are going to interpret them differently if you enter decimal numbers instead of integer numbers. So, anyway, now we have B. If we look at B, actually, the new file that we created, it has basically this number of voxels in the left hemisphere and this number of voxels in the right hemisphere. We have this file that is called fsaverage that contains this img file and this header file. The only thing that we are missing, do you know where we are missing to have this as a proper ROI file? You're missing a labels file. It's not totally necessary, but it's a good thing to have. So we are going to give you now. If you create a text file that has the same name as your img and file, only has an extension .txt. Just write the names of this going to be, we call it PCG left, for example. This is going to be PCG right. You can be as explicit as you want here. This is just to have an explicit definition of the different ROIs that we have within this ROI file. Okay, so now we have this fsaverage PCG set of files that, there's an img and header file that corresponds to the analyze format where you're storing these files, and then an associated text file that contains the labels. And you can use this as a new ROI file in our pipeline and in any other software, and it will interpret it as basically containing two ROIs, one for the combined ventral and mid premotor and motor cortex regions for the left hemisphere, and another one for the same areas in the right hemisphere. Do you have any questions? Do you know how to do that for other scenarios, or do you have any questions on how? The fact that this was an actual, sorry, I didn't mention this, but the fact that this was an actual surface file, it didn't play any role at all in here. If this was an actually M&I file that was in M&I coordinates, you would have done exactly the same. Just take this file, look at the labels, the numbers that you want to create, and create a new file that has ones for those voxels and zeros for everything else. The fact that this was on a surface-based file only makes the particular dimensionality of that file one particular number, and the association, instead of having voxels, you have vertices, but it's pretty much the same. Everything works exactly the same. They are surface or volume-based analysis. Sorry, go ahead. What was your question?
So then I have to prepare an ROI config file that points to this one here before I run this?
Right, or within your ROI config file, enter this as an additional ROI. You can enter multiple files or multiple ROIs within a config file, so all of them will be entered into your analysis. So when you specify the ROIs in your config file, you can just add to whatever set of ROIs that you want to enter into your second analysis. So you can enter multiple lines below the ROIs field, and they will just correspond to different ROIs for that analysis.
Okay, thank you very much.
Yeah. I think it might help. Oh,
sorry, go ahead.
It might help to, well, it might help to have a sort of another, perhaps more linear example, because it seemed like we were kind of solving certain issues. And
Many issues at the same. Okay, so
yeah,
I can do.
we just go through one more so that we just have everything.
Or I can do the whole thing from beginning to end without all of the stops and false false attempts. Okay,
Yeah.
so the way you would do that. Let me see. What is the way that we decided? First we want to identify the file that we care about, which is this LHSLFS average annotation file, and we don't want it to work with annotation file because it's hard. So we figure out which one is the corresponding Nifty file, and the corresponding Nifty file is this one that is called FS. What is it? SL. Should be here. Right. This one. This is the file that we care about. And this file contains all of the regions that we care about, and these were a few hundred, right? So we look at what we did is the first thing that we need to do is associate which numbers actually correspond to the sub-regions within this atlas file that we care about. And the way that we did it was perhaps not the simplest one, but it was this. It was first we read the file using this syntax. Sorry, this syntax. This reads this text file and put it into a huge. We have a huge char array with str within this variable str that contains all of these things. So we want to separate it by lines. So that's why we use this command later on to split this file into different, so from whatever the different lines that define this text file, is going to be associated one for, you're going to get like a cell array separated into one per ROI instead of having just a single char array with all of the names together. Now you have them separately. And then we do this additional thing because it's a trick, because the way that this works is that you had an array of cells instead of an array of char arrays, and we want to have an array of char arrays, and we just use this syntax to convert it. So now in str we have the list of all of that. If you look at this, it should be the 364 or whatever number of ROIs. These are all of the ROI names, and we want to figure out which ones are the numbers associated with those names, because we want to enter into our incalc command numbers, and we do it using this command. Within this str list of names, ROI names, we want to look at these ones, the ones that have these names, and this is going to give us these 8 regions. And then we went ahead and created, already we have the numbers that we care about. So we run this incalc command to create that. And we did it in this convoluted way because we wanted to separate. We really didn't want to combine all of those into a single ROI. We want to combine this 4 and this 4. We could have done that separately as creating 2 different files, right? One for the left hemisphere and one for the right hemisphere. We just did it a little bit more complicated, perhaps unnecessary in this case. We created a single file that contained those 2 ROIs. We just gave ones to the first left hemisphere and 2 to the second one. So we used that syntax. And then we did that trick. Do you want me to show the trick for the integer thing, or do you want me to skip that?
If you think it'll be necessary, then it might be helpful to.
Yeah, okay. Just in case it's necessary, I'm going to very quickly show you how to do that. You read that file using this command, A and B. You are loading that, well, the B is, yeah, it's also necessary. Okay, so now A contains the SPM volume associated with this new file that you just created. And the problem is that the unique B doesn't have the values, the rounding numbers that we care about. They look this weird. And the way to fix that is by doing this syntax. ADT, you make ADT equal to 100. Let me see, where do I have it? Oh, come on. I use a different name. Let me check. Well, AP info, sorry, no, it's not the ADT, I was misremembering. Okay, so you enter that AP info 100, this forces, well, I don't know, I don't want to explain what this does, it's complicated. And then you just rewrite the command, write this other command. And this is rewriting the file, the same file that you just loaded, with the same data that you just loaded, but only rounded, and changing this P info so it doesn't do automatic scaling SPM, and that's the trick why we add this line. And once you have that, basically that has been fixed. The rounding error issue has been fixed. And if you want, you can check again by just reading the file and rerunning the unique thing to see whether it's worked now. But now it looks like actual integers. So that's not necessary. This is just to double check. Okay, so now you have created that file, and the only additional thing that you need to do is to create that label file that we basically edit this and say yes to MATLAB to say that we want to create the file, and we create these labels for these ROIs, for these two ROIs that we just created. And once you do that, then that's the whole process. And you have this new ROI file that you can enter into pretty much all software packages, and it will be interpreted as a correct ROI file that combines this. Well, it has two sub ROIs, sub-regions in it. Right, that the whole original walkthrough was a little longer than necessary as we ran into many issues. But yeah, this is kind of like the summary of it.
Okay, great. Thanks.
No problem. Okay, and do you want me to switch to the other question then, to how to create those spherical ROIs on the surface, if you want to do that?
Sure. Does anyone have any other pressing questions, though, in their analyses that they need to address now?
No.
Okay.
I had one quick question.
Sure.
Regarding, so when I run a second level analysis that is looking at the effect of some, like the main effect of some aggressor. So basically like the correlation between speech minus baseline and speaking rate, say. And then when you run an ROI analysis and the plot comes up and it shows you the effect sizes, and let's say I'm using not speech minus baseline, but normal minus baseline and rhythm minus baseline. So there are two different conditions there. And then it pops up two different effect sizes. Now, are those effect sizes the size of the effect of that variable sort of in each condition?
Right, and you're doing like a correlation with a behavioral variable, right? So for your design should be like ones and then some numbers in the second column, and you are using a 0-1 contrast to look at the second one, right?
Right, exactly.
Okay, so the effect size in there should be the actual regression coefficients, I think, of that linear model. Basically, they are the beta values of the second column, associated with the second column. So they are, and they should be separately for every individual condition that you enter.
Okay.
Even if you enter multiple conditions and look at a contrast that compares the two conditions, you will still get two bars in there. The one showing you the effect in one condition and the other one showing the effect in the other condition. Even though the statistics then will give you just one single number, which is the difference between the two, for example, if you're comparing the correlation across the two conditions.
Okay, all right. Great. Yeah, just wanted to double check that.
Right, and the labels should be, I'm attempting to make the labels as informative as possible. So are the labels like weird or not very clear about, because I could try to improve how the labels of those are displayed, the legend for those plots are displayed, so it's a little bit easier to interpret. So this kernel is in those views of code.
I mean, I guess it just has the label. The label just has the name of the ROI
and the condition or something like that.
And then there's a legend that has the color code for each condition.
Right, but it doesn't tell you what those numbers are. Yeah,
right. Yeah.
Yeah. I mean, right. I mean, yeah. Well, I'll think about it. But yeah, currently it's the regression coefficient basically. So it's a measure of the level of association for each individual condition of what is being displayed. In generally speaking, it's actually showing when you do a contrast across multiple things in your design metrics. It's showing you every column, every regressor that is included into that contrast. That is what in general in the design metrics is for any GLM analysis that you enter. Is, for example, a group comparison, and you have a columns of ones for the first column for the design matrix first column, and then zeros and ones for the second column, and then you're going to get two regressors, and then you're going to do like a 1-1 contrast to compare those two regressors. Then the effect sizes are going to show you the regressor with the first column and the second column, which are going to be in this case the average speech minus baseline over the contrast you're looking at for the first group and for the second group. So it always applies that in general, it's going to show you a list of all of the regressors that are actually included into your contrast. Whatever complex contrast that you specify across multiple elements in your design matrix is going to show you the original regressors before they were combined into that contrast. And it tries to label it in a way that it makes sense. So it's easy to interpret.
Okay, great.
No problem. Okay, so for the spherical ROIs in in surface-based analysis, we don't have. I think perhaps rather than manually doing it, perhaps I can just. Yeah, perhaps we can leave this for the next day, and I can actually add this to the capabilities of the current control box thing. Because in control box you can actually already specify like M&I coordinates and we'll create an M&I file for you with that, like a spherical ROI.
Saul showed me how to do that for a volume.
Right, but you can only do that for a volume. But so it would be like relatively simpler for me to just add the capability to do that on a surface file, basically, so that you specify coordinates. What would be a meaningful way to specify coordinates on a surface? How are you planning to do, like, what is the center coordinate of the surface? Do you get it from a different analysis, or how do you specify those? Or do you get it from M&I conversion of the FS average coordinates of that vertex, or how do you get basically what you intend as the center of the coordinates of the sphere?
Well, I think the fact that we're getting these coordinates in some volume space. So I think originally they're in Talairac, and then we convert them to M&I space, and then I guess it would be the nearest point on the surface might be the most appropriate.
Right. Okay. So perhaps like an M&I coordinates. So you would still enter M&I coordinates, but then the software will look basically which one is the vertex that is closest to that M&I coordinates, and we use that as the center. Right. That makes sense. Do you think that would be appropriate in for your use case?
I mean, I honestly don't know. I don't have the expertise to say. Perhaps we can ask Greg at the lab meeting.
Right. I mean, in this circular surface. So what these coordinates that you have right now, they are the ones that you are attempting to use, basically the ones that are being displayed in that plot.
Yes.
The meta-analysis. Okay, and this is. I think those coordinates might have been originally defined in the M&I space, right? They have only been projected to the surface for plotting purposes in here, but they were originally defined in the M&I space because they probably come from other studies which were based on
in the publication, they were defined in Talairac space, and then I converted them to M&I.
And why Talairac space, do you recall?
There's the ALE. I don't know if it's ALE software, but all of these ALE papers have
just coordinate. Okay, yeah. I see. That's an additional level of complexity, but yeah. Okay, so I think in that case, then probably just then I can assume that you can enter you're gonna be entering M&I coordinates for the vertices that you care about, and the software will just make sure that projects those M&I coordinates to the closest point on the surface using the FS average projection, basically. Okay. So yeah, I think for this, rather than manually showing you how to manually do it, which is a little bit convoluted actually to do that, it would be simpler for me to create the functionality to do that in using basically the same software that you're using right now for the volume base, and then I'll show you how to do that using that software. So we'll postpone this for the next meeting if that's okay with you.
Sure.
Okay. Any other questions or issues that you would like us to talk about?
That's it for me. Yeah, interestingly, well, based on the volume-based analyses I didn't find any differences among the two groups of these nodes. So it'll be interesting to see if Saul gets a different result in his study.
Yeah, no, I actually found. If I can find them. Yeah, I didn't find any significant differences, and they're the trend of the difference was actually in the opposite direction of that in the meta-analysis paper. Wow. So in the left, like the more inferior, what they call in the original paper left middle temporal gyrus, it's like clearly in the opposite direction, where instead of these being areas where people who stutter have lower activation, they have consistently higher activation across both conditions. So
in which area?
Yeah. Which one? What?
Which area?
In the original paper, they call it left MTG. I think that you might have used that when you created it.
These two.
So the one that's more inferior.
Yeah, so this
Yeah.
one.
I can't see.
Oh, yeah.
These ones here.
Yeah. Yes, for both of those, they were trending in the opposite direction, where there were actually greater activation in the stuttering group. So I don't know what to make of that.
I think we conclude that science is difficult.
I think I saw this guy's name on the program for the symposium this week. I don't know if he'll actually be here or not, but I saw he was an author on one of the posters.
So you can confront him.
Maybe we
Ambush him. Yeah. Well, I mean, I'm sure. I think the results of the analysis are consistent with what's in the literature. So it doesn't seem like there's much wrong with the analysis that he carried out, but it just looks like our data are for some reason not aligning with that, and I don't know why. But yep.
well, many thanks, Alfonso.
Thank you, Alfonso.
No problem. Okay. We are already kind of like formalizing the Monday schedule, right? So we should reconvene basically next Monday, same time.
Sure.
Yep.
Okay, fantastic. Okay, so let me know if you run into any issues or have any questions.
Alfonso.
Sure, go ahead.
Before you can stop recording, but for the